Good afternoon. Hey, welcome to AmsterBased 2022. Woo! So many of you don't know me. My name is Keith Salzman. I'm a ZK developer. I work at the ConsenSys Mesh, also part of applied research and development for the Baseline protocol. I'm going to be your host today. So for you here in person, of course, you guys know that this is our Baseline protocol community event for EthDevConnect. If you're listening in virtually, maybe that's the first time you've heard this, but we have a lot of really interesting things lined up for you today, a lot of various topics. So I'm going to go over our schedule really quick and then hand it off. So, of course, we have interesting talks from Samrat, Stefan. We have some juicy Web3 stuff, whatever that's about, I'm not sure, from Anton. And then, of course, we have a presentation from bloXmove. So we're going to have like a short break between each presentation, and the presentations go from like 15 to 40 minutes, right? And then, of course, the last 2 hours of today, we're going to have happy hour with drinks. And the last hour of that, from 6 to 7, we are going to stream the Baseline show of the week, right? We're going to stream that for you here. You can either be present here just by listening or just log in virtually if you want to engage in the Q&A chat. So depending if you're logged in from either Taikai or YouTube, I believe on Taikai you're going to have to move over to the YouTube stream if you want to be part of the chat there. All right, and without further ado, I'm going to hand it over to Samrat Kishor. He is our TSC and co-chair of the TSC, Technical Steering Community, for the Baseline protocol. So everybody, give him a hand.
Thank you. Okay, thanks guys. Beautiful Holland day. Thank you all for making it to this event. It's an amazing day, actually. It turned out to be very, very interesting since we started off. We were planning to have this venue. It's amazing. And kudos to all of you for making it today. Thank you. So I welcome you all on behalf of the Baseline protocol. It's very interesting to see people. I mean, I've been involved in the Baseline protocol since the beginning, almost the beginning. We were the new kids on the block in 2020, March of 2020 when we started off. And today it turns out to be a huge community. We have over 50 core devs just doing Baseline stuff day in, day out. And you see a couple of them right here. So just find them in the breaks or after in the happy hours, and definitely make sure that you're part of today's Baseline show. And some of you may have seen me blabbering on the Baseline shows anyways, right? So I'm not going to take much time today. I'm just going to set some things right for people who are new to the community. I welcome you all. So we have, starting off, big thanks to all our sponsors. Really, we couldn't make this possible without the sponsors. So thank you so much, guys, for making this possible. We have Mesh, of course, our biggest sponsor. John is from there. And we have bloXmove, we have Unibright. Thanks, Jack, for being around. And then there's Mover and Taikai. So thanks all of you. We have presentations from our sponsors as well today, lined up, as Keith just mentioned. I'm just going to start off with Baseline. What's Baseline? So it started off as an open source community in March of 2020. We have the founding members as ENY, ConsenSys, and Microsoft. So I think we were standing on the shoulders of giants when we started off. I think that was something good. We had a good start. And now we have official sponsors who are 15 official sponsors. Big names, SAP is there. There's EEA, of course, has been a strong believer. Accenture is there. Big names have come in. And there's ServiceNow as well. I see them missing. Splunk is there. And of course, the amazing people from Provide, Unibright, the up-and-coming communities. So you see all of these companies are building Baseline day in, day out. That's extremely, extremely powerful for us. The only analogy I could come up with for Baseline was the sliced bread analogy of how sliced bread came into being after ages of bread being existing. So in 1928, this gentleman called Otto Roverder, he came up with a machine to slice bread, which was already available. So bread had been around for 30,000 years, but he found a way of slicing it, and hence giving rise to new commercial models like sandwich shops. Similar ways, what baselining is, it's using ZKP, it is using blockchains which have been existing for a very long time now. It's just putting it into a new pattern. It's just a way of doing things differently, which is now called baseline. So I'm just comparing it to sliced bread. That's very cliched, but that's true. So, that's with that. I have the diffusion of innovation curve. Now, what happens with diffusion of innovation? Any new thing which comes in, there is always a strong community which believes in, who are the early adopters, and there's a very strong community who still believes the Earth is flat. So they are the laggards. So where we are currently is the early majority, I would say. That's my perception of things with baseline. We are done with the 2.5% innovators. We've crossed the chasm with the communities surviving one election, some disputes here and there, and then a lot of new developments, new releases. So I think we've crossed the chasm. We will now exist. That's the point of no return. And then there is the early majority. So now is the time that if you are joining in today, baselining, congratulations to you, because you have been given the gift of a well-built community, a solid core dev team, and a lot of content also to support business cases in the days to come. So that's where we are. And congratulations to you. I hope that you make it big before the late majority also comes in and this becomes commoditized, right? So let's make a lot of money doing this. And then there is the real drivers of innovation. Why I say that it is important to have events like these. This is our maiden event. Thank you all again. You're our first audience who's listening to us in person. There's a lot of people who hear us on baseline shows every Wednesday, Thursday, and Saturday. So it used to be, my show used to be Saturdays, but it's now Thursdays. So the real drivers of innovation are creativity and curiosity. That's what I call the two C's leading up to the ecosystem. So this is the ecosystem that we've been waiting for, that new people come in, join us, think of new ideas. We're also running blips, which are baseline improvement proposals. So you can come in and you can bring in your own ideas, how we can do baselining better, how we can add more components to it. You can also propose some grants for these blips. So it's all so it's all the ecosystem play, and I think what we are doing here is purely focused on ecosystem. So, but keep your creativity and curiosity alive. All right. With that, let's see. I need you to imagine. So that's my last message. I want to leave you with this. Please imagine things which can be done with baselining, and come up with new business models, new ideas, which we can together take to market. There are huge companies involved already. So I have not seen a team which is struggling for funding. I've not seen a team which is struggling for getting the right dev support within baselining. You post a question on Slack, you get an answer within 15 minutes. That's super awesome. There is no TAD, nobody's getting paid to do it, but still being done. All right, so it's very, very, very active community. Awesome. I just want to thank these two people. They've been solving, they've been posing a lot of problems for all of us. So big thanks to Alice and big thanks to Bob. Please give them a big hand. A lot of our problems that we're solving with baselining starts with them having business issues. You're going to be hearing about their business issues later part of today. But these two people, they're good at heart. They want to do business. It's just that they have some problems. So let's build good systems for these two people. Awesome. With that, I bring back my sponsors. Thank you guys once again for making this possible. We love you. Cheers. So I am supposed to bring in the next speaker as well. Sorry. So with that, I bring in Stefan Schmidt, who is the co-founder and CTO of Unibright, our beloved company. And they went live very, very recently with their Baseledger. So we should give them a big hand. So welcome, Stefan. He's going to be virtually with us. Hey.
Hello, everyone. I hope you can see and hear me.
Yes, that's
the
perfect.
only thing I see is myself twice, which is interesting. But I will have some synchronization with myself. This is a good baseline example, actually. Just kidding. My name is Stefan. I am a CTO and co-founder of Unibright. I'm also Baseline TSC member. Yeah, some words about Unibright. We're a blockchain integration company from Germany, founded in 2017. We offer software, services, tools for connecting IT systems with the help of blockchain technology. So the Baseline protocol was a perfect fit for us, definitely. Yeah, thanks for having me here, at least virtually. And thanks to all who made this event happen. Thanks for the intros, Keith and Samrat. And I will now share my screen. Please let me shortly know if you can see it. Okay, I can't see any feedback here, but I will just continue considering that you see the screen. Yeah, today I want to give an example on using Baseline by using Baseledger in the context of synchronizing music streaming reports. My presentation contains of 3 parts. First, a short intro on the music streaming context, then a short overview on Baseledger, our blockchain for baselining, and then an example on how Baseledger can be used for synchronizing, not only for data from the music world, but this is the example for today. I will start with a short disclaimer from my side. Besides being a computer scientist and software architect and entrepreneur since around 20 years now, and in this role working for Unibright, I'm also a musician. So my band Van Canto exists since 2006. We released 8 albums so far, of which 6 reached the top 50 album chart positions. And as a producer and arranger, I also participated in more than 50 productions. The last time I visited Amsterdam was on the 2018 European tour with my band. So this photo was taken pre-COVID. Here you can see a small impression from the after-show party in the Melkweg in Amsterdam. Very nice venue. You should check it out, but I'm not sure if they reopened yet. I'm telling all of this because I will be talking a lot about platforms today, and both Martin and me as the Unibright co-founders have always publicly presented stuff that we really know what we're talking about. We are better in getting things done than announcing stuff or perhaps talking about stuff that we are not so good at. So as Unibright has not been perceived as a music biz venture mainly, I think this context is needed so you don't get the feeling, why is this Baseline IT guy suddenly talking about Spotify? That's an important thing. Yeah, so here's why. Spotify is only one streaming platform. I made a small statistic check yesterday and took this screenshot. So until now, my band comes to around 2.8 million distinct listeners on that platform alone. You can add some zeros for the number of streams, of course. We have 8 albums, we have 8 members, we had 4 different record companies throughout our career, from our first self-founded one up to Sony Music. We have license partners and contracts all over the world. So you can imagine there's a lot of reports on licenses, royalties, and payouts happening. So much for the music context. We will return to that later. So what does Baseline and Baseledger have to do with that? Baseline is about multi-party workflows, and Baseledger is the Unibright implementation of the Baseline pattern, as Baseline is a free standard and you need implementations that actually put this into product. So Baseledger is our own blockchain where the mainnet implementation went live some weeks ago. Baseledger is an enterprise-focused blockchain offering the main features for enterprises that want to overcome the, let's call it, let's do a POC phase and want to use blockchain in production. So for the key features, data privacy, Baseledger is a public council-governed blockchain, so companies do not have to set up new silos or private blockchains, but they can still consider the data safe and stored in a GDPR-compliant manner. Baseledger puts a lot of focus on integration. So this is, of course, as an integration company, our core request to not only offer a piece of infrastructure, but also working on connections to existing IT systems. Service quality is a very important point for enterprises that want to go into production with a blockchain-related implementation. So Baseledger offers a reliable cost structure driven by our own token UBT, but calculatable on a fiat-based fixed price based on the transaction size, which is very important for enterprises that are setting up long-term integration processes and want to know their costs for the upcoming months and years, of course. And a unified architecture, meaning that Baseledger can work standalone or can be integrated in a multi-chain setup, for example, by anchoring Baseledger proofs on Ethereum if needed. Yeah, and some small remarks on the token model and UBT as the token that drives Baseledger. UBT is an ERC20 token on Ethereum, and it's used both as input and output token on Baseledger. So the way it works is clients or users that want to use Baseledger and store something on that blockchain, like a proof, they have to bring in UBT into a smart contract, and then they get an amount of transaction that they can use inside Baseledger. And this incoming UBT is never touching any of, let's say, Unibright's accounts or anything. It's just a smart contract that is council governed. And this UBT coming in are distributed to all the stakers and validators that ensure the security of the network. There's also proxy staking models. So some of the stakers can have proxy stakers on their own. We have solutions on Geyser and Mover coming up. So just to give some context, we are or Unibright started as a enterprise also in the crypto world. So we have our own token, and there had been a lot of discussions. Why would you need your own token? You can do it with fiat or whatever. But as soon as you're talking about a blockchain infrastructure and really an ecosystem, a healthy, growing, organic ecosystem, then using a token to secure the network and to both pay for transactions makes totally sense. And this is also one of the things that we understand under service quality, that enterprises can actually make use of such a token model to use a blockchain. Some Baseledger facts. Our mainnet went live in March, driven by UBT as input and output token, as just mentioned. And now, around 4 weeks later, we have about 50 million UBT staked as for the validators, which means 10% of the total supply. We were completely overwhelmed by that, to be honest. We didn't expect such a high pickup rate. So very great to be in such a healthy community and ecosystem. We have 17 validators and onboarding new ones like on a weekly base. And currently we already have like 3,500 proofs per hour that are dropped on Baseledger. So Baseledger itself is a proof of stake blockchain where the main purpose is to store proofs efficiently. Proof can be like a string of some kilobytes, and you cannot calculate back what this proof means or who dropped it. So the privacy part, of course, is a very important thing inside Baseledger and Baseline. Then we have the Baseledger proxy, which is our open source Baseline implementation, giving all the features that the Baseline pattern needs, like workgroup management, off-chain messaging, proof calculation, the TrustMesh thing that we will show in the example later, and also a REST API and native Baseledger connection. And there's also already some ecosystem around Baseledger. For example, ConUBC is an SAP certified blockchain connector developed by ConsenSys and Unibright, which is already live in the SAP store, so that you also do not only have an infrastructural component, but really think it like from end to end from a user's perspective that want to make use of blockchain technology and integration processes. So, yeah, how can an enterprise use Baseledger and make use of the Baseline patterns? Basically, Baseledger can be used in all business scenarios where two or more parties, Alice and Bob, or party A and party B, exchange and synchronize data. This data can be purchase orders or lending requests or certificates on steel production or streaming reports and music. The parties synchronize a piece of data. They both agree that the synchronized data is correct and notarize this agreement on a blockchain on Baseledger in this example. So this alone already is a great add-on for all existing integration processes, as the act of notarization adds a tamper-proof timestamp on the agreement of both parties, which can be used afterwards by other parties when it comes to continuing the process or building adjacent products on a state that has been notarized. The baseline protocol itself often mentions zero knowledge proofs, which is a proof to a third party that something happened without the need to tell the third party what exactly happened. So this is also possible with Baseledger. Baseledger stores proofs or results of synchronization agreements, and Baseledger proxy also contains logic and tools for limited knowledge proofs as well. And here in the slide, we also see the connector part, which I referred to earlier, like the SAP connector. So you always have different parties that connect to a stack that enables the baseline pattern, like the Baseledger proxy, and then store proofs on the Baseledger. Yeah, given that, I want to make some small remarks on use cases. Personally, I think it is a mistake to try to compile a list of baseline use cases, because any list always gives the impression that it's also a limitation to the use cases that are listed. So that's why I prefer to show examples. Like in this presentation, it will be an example from a music streaming platform, but Baseline or Baseledger is of course not limited to the music industry or to supply chain or to finance or to the steel industry or whatever. It's just a pattern. So when we compare it with, for example, email coming up some decades ago, I don't think that people ask, we have to come up with use cases. Can email be used in supply chain? Sure, it can. But an email is just the communication pattern or the technical standard, how to exchange messages. And then software like Thunderbird or Outlook implemented the standard and added some user-oriented features. So you will not find a list like steel industry, finance, and music industry on the Outlook product page or on the Wikipedia entry around email, because it's just the pattern. And this is also the case with Baseline. So the pattern that we focus on is, as I said earlier, party A and party B, the work group, synchronize a specific piece of data or a new version of existing data using the Baseledger proxy, for example. And then they notarize this synchronization act on Baseledger. And optionally, if a third party appears, they can prove that this synchronization happened. So for example, that the third party can build products upon it. This multi-part synchronization of different versions and approvals or even rejections of new versions is stored in what we call a TrustMesh and what is then notarized on Baseledger. So a TrustMesh is the full graph of all versions that party A and party B synchronized on, including the notarization part on the blockchain. I don't want to get too technical. I think the developers among you should check the docs at the GitHub. The scope of this presentation is more to come to an example. So here's a small example of how a document looks like that was synchronized via a TrustMesh synchronization. So on the left side, you see like a tree, which consists of some attributes of the data exchange. This is the leaves. In this case, it was a purchase order, which has an ID and a discount. And on the upper levels of the tree, you see intermediate hashes that are created by combining the leaves, the string value of the leaves, and calculate hashes out of them. And you can do this level by level until you reach the top of the tree, the root of the tree. And this is the value that can be stored in Baseledger. So the data itself is exchanged on a private off-chain layer, for example, on Nets or whatever fancy protocol or technical solution is there. And then you store the root of such a synchronization, for example, in Baseledger. And this way, you can also limit knowledge to a third party that wants to see that the synchronization happened, but perhaps is not allowed to see, in this example, the discount. So that third party would only be sent a subset of the leaves, only, in this example, only 3 or 4, but all the intermediate hashes that were calculated in the intermediate layers and also the root, so they can recalculate the root hash and compare it with the one stored in Baseledger without the need to know all of the detailed attributes of the exchanged object. For all those that are interested in how this works and how it's implemented, there's some material around Baseledger, of course. The most important one from a developer perspective would be the GitHub, github.com/Baseledger, where you can have a look at the open source proxy implementation and the TrustMesh that I just showed, including a visual component that shows TrustMeshes as part of the open source implementation there. And from user perspective, if you just want to see how Baseledger as a network works and grows, you can take a look at the Explorer on Baseledger.net, looking at the validators, the transactions, and so on. In this case, let's take some roles from the music business. Usually the streaming platforms, so something like Spotify or Amazon Music, report the streams to a record label, and the record label pays royalties to the band or to their bands with a specific share. Some bands get reports on all physical and digital sales, like every month, perhaps every quarter or twice a year, doesn't matter. And the idea, if we approach this from a baseline perspective, if you think of notarizing the streams, of course not the audio streams itself, but the fact that they occurred and that somebody clicked on, I want to listen to this or that song, say on a daily basis on Baseledger. The band, for example, could be the party C, which is now able to verify the number of streams that were reported to the record company without needing to know, for example, the exact amount paid to the record label, or the other way around, perhaps learning about the amount that was paid to the record label without needing to know a specific distribution of which song was streamed at what daytimes or regions. So the important idea is that the use case, which I'm not a fan of calling it use case, more the example, makes sense if platforms synchronize and use the baseline pattern. It's not so much or not so interesting, in my opinion, if you find that one shiny customer that says, yeah, I am using the baseline pattern. Like if you would find one band that agrees with their record label that they are now baselining their streaming reports. Of course, this is also added value, totally fine. But the real value comes if you think of this as platform-based, like a streaming platform that already have the connection to the record label, and they already report all of the streaming, so the record label can take them in their ERP system and build reports for the bands out of that. And to put an integration component via baseline on top of that existing one is what I personally think is the real, or will be the real game changer in baseline adoption. Of course, we all need these examples and small use cases to explain who Bob and Alice is, but the real fun starts if we think about platforms that are implementing this pattern. In the same context, you could think of another instantiation. So think of a producer or a production company that creates a band or a concept, a worldwide tour, whatever, and the band agrees to a deal with getting shares of all royalties or incomes, no matter if they're from CDs or streamings or merch sales, so t-shirts and stuff. So these 360-degree deals, they were very popular in the first decade of the century, and many of them are still active because the bands are still active. So now think of the situation where a new member joins that band after 5 years where the deal has already been in place. And that new member, perhaps she wants to be sure that all the royalties in the deal were synchronized correctly before she enters the same deal. And perhaps the band or the former member does not want her to know the exact amount that was paid by royalty, but she wants to prove that the synchronization happened and that all the parties involved, it's only 2 parties here, party A and party B, but could be several parties like producers, record companies, merchandise companies, that they all synchronized correctly on this data and on these reports, and that they all agreed that these reports were correct. Now we're only talking about, let's say, real world existing parties like a band or a producer. You could think about something where it even gets more interesting if you're not talking about real musicians, but AI-generated music. So just a small excursus, Unibright Ventures is currently participating in a venture called Metalverse, where AI-generated music is democratized by community participation. So think of it like all of the democratic processes in a band, like songwriting or picking the artwork, is controlled by a community, which votes on the parameters of the artificial intelligence that creates the music. If you want to take a deeper look, you can check out Metalverse_AI on Twitter. And the baseline related instantiation of that example would be that you have still a streaming platform as party A, and you have that AI band or a software system that creates music, and you have a community, perhaps with thousands of people that are somehow part of the process, and they want, for example, to prove that these streams from the AI band on Spotify were really reported without having to know the details of the deal. Or in another scenario, if you think of the band like a DAO, the community could be proving that the revenue share was correct without having to know the details of exact streams on every platform or something like that. Again, this is an example where platforms are synchronizing, and that's where it really gets interesting. And in the case of Baseledger, it's also important to mention that all these enterprises or platforms or single clients can use Baseledger without applying for it or going public with their intentions. So now being a Unibright related venture, of course, I can talk openly about it, and we explore all the possibilities to use the baseline patterns and Baseledger within these new ventures like Metalverse very openly, and we're happy to present them. But from a baseline perspective and from a Baseledger perspective, I am personally equally happy about every user that just uses Baseledger without the need to, I don't know, join a Discord or a Slack or a Telegram or baseline office hours, although they're always fun to watch and fun to participate. But I mean, talking about privacy, it's very important that we build all this ecosystem in a way that enterprises just can use it and perhaps do not want to have the public appearance part of telling the world, now we have a new boring IT system. They just should be able to use it and take the benefits out of it, which the baseline patterns and the baseline content clearly bring. Okay, I think all of these topics would deserve an own presentation in my feeling, but at least before closing, I want to point on some references. Unibright.io and UBT, the token, is of course a good source if you want to learn more about the company and the token model. Baseledger blockchain, you can have a look at baseledger.net as the landing page to get all material. The Explorer I showed before is more to see what happens actually on Baseledger with which kind of transaction. Developers perhaps have a look at the docs at Baseledger.net or the GitHub. If you want to learn more about the SAP part, which we haven't covered at all in this presentation, there are many presentations also online where we showed SAP screens of purchase orders, but I didn't want to do that again. But you can check out Concerto.com with the SAP connector. And of course, I mean, that's quite obvious as you're in the audience because you're interested in Baseline. You all know baselineprotocol.org. And yeah, I mean, there's a big community around who's actively working on that every day, not only in the Baseledger context, but also in the Baseline context, that work on new material, new examples, do conferences like this. So yeah, everybody that helps to get the word out clearly helps a complete ecosystem and not just single companies. Yeah, thanks. So far from my side, I don't know exactly what the agenda is. If we have like a question and answer section, I can't see or hear any of you, so I will just stop sharing my screen and wait for further instructions. Thank you very much.
All right, everybody, another round of applause for Stefan Schmidt, woo, CTO of Unibright. I think now we're going to take a short break, 10, 15 minutes. You can stay here and kind of ruminate on that great presentation of what he's given to you and just let that sear into your brain. Or you can get up and go get some snacks or whatever. And then next up is myself. I'll be giving a small presentation on the basics. Right here, baseline architecture simplified for everyone. So that's it. Thank you for listening, and make sure to come back. Thank you.
try to do my best by him, but I always let him down. I'm always finding time, but when he asks me, I'm busy.
Hello, all. Welcome back. Good afternoon. As you all know, my name is Keith Salzman, ZK Dev, part of the Applied, again, R&D team for Baseline. That's a really great picture of me. Yes? It's right there. It's in the picture. All right, and so today I'm going to be giving a talk called The Basics. Okay? So one thing that we've kind of found with, introducing Baseline to people, it can be difficult as a topic to consume in a single sit-down, right? So we strive in these conventions to at least have one talk to go over the Baseline architecture, what we call Simplified for everyone, right? I think it's a pretty great name. We came up with the acronym first and just plugged it in there, okay? So if you are an advanced baseliner, maybe this talk isn't exactly for you, although hopefully you can glean some things about the kind of architecture behind the scenes just from the standards point of view. And if you are totally new to Baseline, or you've been involved a little bit in some of the open source, or even if you are not tech savvy, although I will dive into a couple of techie things, I think this is a great place for you to start and get an understanding to kind of develop those mental models in your mind that are really necessary to make it over that initial learning curve of understanding, what are the concepts behind Baseline? What are these strange, fluid architectures behind the Baseline protocol itself from a standards point of view? So there are a couple things that I will ask you to keep in mind during this talk, especially if you're new. That I'm presenting from the point of view that, the Baseline protocol, it is a protocol. It is a standard, right? So while other talks may be showing specific implementations, and those are great concrete examples to wrap your mind around, at any point in time, if I'm showing you some diagram or something, and you ask yourself, well, where is this thing? What does it exist? Maybe we're just saying it is existing and it is acting as it should be for the point of this example, right? And that the implementation in real life may look very different depending on the actual case. I wouldn't say use case, because Stefan doesn't like that. The example, right, that you are implementing, right? Okay, I think that's it. Are you guys ready to begin? You have your brains primed? Okay. Okay, there you go. So before we kind of dive into a real simplified example to kind of elucidate some of the architectures behind the implementation, or behind the protocol, the standard itself, just, of course, starting off with a little bit of background. So, of course, we have Baseline Protocol launched March 2020. We have the co-founders, Microsoft, EY, ConsenSys, open source standards projects. So, as most of you probably know, you can get involved in any part of Baseline, whether if you're a dev, if you just want to be part of outreach, PR, really anything. All parts are open source. Anybody can get involved. This project is governed by OASIS, the open standards body. And of course, we have plenty, as you can see, all of our icons of all of these great sponsors we have here. So many great icons. Please look at them now. Yes, some of them are here today. Some of them are not. Okay. And just to kind of set the baseline, set the ground behind, what was the initial question kind of asked? And of course, I was not there during its inception, right? But what was the initial question, or something close to it, that Baseline, or the co-founders of Baseline, were kind of asking themselves to solve? Well, if you listen to Stefan, you probably got it, right? Which is that, in today's world, we have all of these enterprises who are holders of this complex data, and they are attempting to, or should be attempting to, communicate with each other, right? And although that does happen today in some form, that this can be very problematic in terms of how do we speak to each other in an efficient, low-cost way where we can guarantee we are synchronized and we have security, data integrity, all these things, right? So that is the kind of the baseline of the problem that the baseline protocol was seeking to answer, right? And so try to keep that in your mind as we go through. Now, so baseline, of course, has reimagined the way this is going to happen. And all of today, we're going to go through how that reimagination was built. We're going to look at it from a very simplistic point of view, right? So again, anybody can understand, all right? But again, before we dive in, I'm going to keep saying this, before we dive into architecture, because if we dive straight into architecture, I think we'll lose especially, maybe not anybody here, maybe you guys are hardcore baseliners, but the virtual side. So let's start off with a definition. So what is a baseline protocol, right? Try to carry this definition in your mind. We have a standard that enables two or more state machines to achieve and maintain data consistency and workflow continuity by using a network as a common frame of reference. So this is very, very basic, right? We have the standard baseline itself, a guideline, a railing for how to implement this thing. Two or more state machines. Today, we're going to focus on two parties, two state machines, but you can imagine, how this will expand to, in amount of state machines, in amount of parties. And we want to achieve and maintain data consistency, right? We want to always be synchronized, and we want to be sure that as we execute and move to the next state that we are already synchronized and hopefully in a trustless environment. So, and workflow continuity by using this common frame of reference. So we want a common frame of reference. We're going to see in today's presentation what I'm going to keep calling a CCSM, or a consensus-controlled state machine. For many of you, of course, that means blockchain, right? But really, it could be any distributed ledger technology of any type, right? So the second definition here, the set of tools and libraries, I think this one is a little bit harder to wrap your mind around. You may be asking yourself, where are those tools and libraries? Well, the simple answer is that inside the baseline repo, while there are core packages that will help kind of define or interfaces of how and what tools should be implemented, that really, if you're looking, again, for those concrete tools, you're going to look out for those, outwards towards those concrete implementations, okay? So let's try to keep that in mind, all right? You guys got it saved in your brain? I see a couple of yeses. All right, there are these terms and concepts. I'm going to keep coming back to the slide if I can, if these buttons are fast enough, in case we need to define some concept from a diagram that we're looking at. There's a couple of things here. Again, the consensus-controlled state machine that I mentioned, CCSM. We have a couple things, a work step, a workflow, a work group. Right now, I'm going to focus on the BPI, right? So the baseline protocol instance, or sometimes implementation. So really, for us, these are logical constructs. They're shared, between transacting counterparties of, let's say, requesters and providers, and implemented on the CCSM. So I think it's difficult, unless you've been part of baseline for a while, to really, wrap your head around, what is this baseline protocol instance, and where does it exist? Out in the ether, online, off-chain, on-chain, and we're going to discuss that a little bit. But for a lot of the diagrams, we're just going to assume this thing has been implemented properly and try to see the overall flow, okay? In the next diagram, we're going to look at work steps, workflows, and work groups. So, within a baseline protocol instance, we have like a set of parties that want to engage in some transaction. In the examples I'll show, it'll be simplistically just like a purchase and order thing, right? It could be anything. It could really just be sending a message from one party to another. In this case, we're going to be buying some product, a buyer and a seller, okay? And we're going to look at the flow of just a work group from a high level, and then I'm going to dive into, in detail, how we go through the flow. So let's go ahead and do that right now. So, all right, here is a workflow diagram. This can be found in the standard. I like to use all of the pictures and diagrams and everything from the standard. In that case, that after my presentation, I know you'll be thirsty for more knowledge, and you're going to go straight to the standard and read all the way through it, right? And you'll notice that we're using the same diagrams. You'll be like, aha, I've seen this before. I'm familiar. So here we have an example workflow. And in this workflow, let's say we have this work group, so a group of BPI subjects that have gathered together based on some agreement between them. So for example, if this was a buyer and a seller, and they have some agreement of some product that they're going to transact between them, right? And we have a work group B. So work group B could be, let's say, maybe in this simple example, something with a seller and a manufacturer, or so on and so forth. So again, the examples today, they're not exactly going to mirror reality, but just, again, for simplicity. And let's say work group A member has some input for this work step, so that could be an actual purchase order, right? So if they decide to purchase something, and they may include, based on the agreement between the buyer and seller, the two parties, that information they've agreed upon, as well as some kind of, let's say, proof. In a lot of instances, you've seen us mention maybe zero-knowledge proofs. It doesn't exactly have to be a zero-knowledge proof, although hopefully I'll have time to get into why I think it should be, but some sort of proof to say that we have done what we need to do according to our agreement between them, and that work step will then, let's say, be the flow between the buyer and the seller will verify that proof, let's say, do what they have to do, and then there'll be some output, a change in the overall kind of shared state of the BPI itself, right? The state object that is passing that output will then become maybe an input to the next workflow, which could be something between a seller and a manufacturer. Just for example, it could be really anything at this point. And of course, work group B will have its own BPI subjects. It'll be governed by some master agreement or agreement that they have. And something similar will happen here. Again, transaction of data, messaging, depending on what's within that agreement. And then, of course, we'll have an output and so on and so forth, okay? All right, so this is just a flow for a simple purchase order, let's say without baseline protocol implementations or ESK things going on. And I think I'm not going to follow it all the way through, but if we take a look, I think it's easy for most of us to imagine, okay, we have a request for a purchase order. We create the purchase order. It's been approved. The vendor receives it. We create an invoice, and it kind of goes back and forth, right? So there's not to say that there aren't, of course, guarantees in this current system today, but it's easy for us to see how this can get messy, right? How, maybe we go down through the flow and realize something is wrong, and we have to back up. There has to be some kind of manual reconciliation, and at what cost does that come, right? I think everybody here or online has obviously dealt with these kinds of things in their real life, and it's easy to imagine how we can have these systems in some kind of weird asynchronous state, and so on and so forth, right? So we set the stage. This is kind of the problem we're talking about. It's very simplified. There's two parties here, but as you blow this up, between n number of enterprises, the problem is exponential, right? All right, and so here is that kind of solution applied, the baseline protocol solution applied to that situation. All right, so this is where I'm trying to make the connection of, hey, that's the problem we had before. Now we're going to go through the actual flow in detail. I'm going to go through the flow in detail of, how do we guarantee that we can avoid having to go synchronization and all in, let's say, hopefully a trustless environment with ZKPs, again, my preference. All right, so we have the BPI in the middle. We're going to assume we have a correct implementation. It's doing whatever it needs to do with whatever specific implementation technology that you're working with. We have the buyer and we have the seller, okay? So let's say they already have an agreement between them. There's already we call it an MSA, a Master Services Agreement, between the two parties here that are in the BPI, in their own work group in the BPI. And that contract logic, which I'm going to say it's like a codified contract logic, they may have an actual like legal paper presentation between them or representation between them, but we're going to codify that logic. It's going to be part of the BPI into the CCS system. Again, we're assuming that is able to work and function. And let's say the buyer wants to make a purchase, right? So they make some kind of API call that will validate their order, what they want to order from the seller against the contract logic itself. So the contract logic that is living in here that dictates the rules of how these two parties interact, what's okay, what's not okay, already holds the logic to say, okay, well, you want to make this order, then you're going to have to provide this certain specific data, information, whatever it is. They do so, and then the BPI itself has this tool to generate a cryptographic proof that we are in compliance, and we can then update the contract state that this purchase order is in compliance so far, right? Now, what that cryptographic proof is, again, we're not worried about that right now. I keep having to make plugs, I feel like, for ZKPs, but there could be really any proofs that you want to use at this step, at this implementation, right? And so let's say we return that, the API responds with the cryptographic proof of compliance, and now we are ready as the buyer, if we see ourselves as the buyer, we're ready to send that proof off to the seller, right? Now, how we send that to the seller, whether in this diagram seen as moving through the BPI, or if we've set up a relay or some kind of messaging protocol directly between them, we're not going to get into the specifics. We're just going to say we have a way to transfer that message protocol over. We're going to submit the order with the cryptographic proof. So we have all that data required by the seller, the proof that we are in compliance, maybe hiding some private input, and we're going to send that to a place the seller can retrieve it, right? The seller retrieves it. They get the message containing the order and the cryptographic proof. The first thing they want to do is they're going to want to validate the proof, right? Again, in this case, simplistic, we're thinking of a single proof. It could be multiple proofs, right? Depending on the example. And so we're going to, as the seller, if we think of ourselves as a seller, we're going to validate that proof against the BPI. All right, so we validate that proof. At this point, we're either going to get a positive or a negative result. So if we get a negative result, we already know that whatever was sent to us, it is not compliant with what we agreed to, right? It doesn't need to go beyond that. This is not a valid order, right? But if we get a positive result, we have verified this proof, and then we say, okay, this is a valid order, and now we need to do what our side needs to do, which is to take the data or information from our system to say that we are accepting this order, whatever the order is, and we're going to do something very similar to what the buyer did, right? We are going to make a request to the BPI to generate the order acceptance from the contract logic. So again, dictated by this service agreement that are between the two parties, just as the buyer did when it first generated the cryptographic proof that it's within compliance, that its order is within compliance, that now the seller accepting that order. And again, you can use your imagination of what parts of, what data, what's going to be input here for them to make sure they're within compliance. And then they're going to do the same thing. This will generate a cryptographic proof that they are actually within compliance, and they will bundle that up with returning acceptance of the order, and they'll send that back by some messaging protocol to the buyer, right? So now at each step, we're kind of having this state change, right? You can think of it as like a single state object that's kind of moving in between. Here it starts off as the order with the proof created. It's validated, updated with the information the seller needs to put in, also bundled with their own proof, and then kind of sent back to the buyer to say, yes, everything's good, everything is in compliance on both sides. Let's send it back one more time so you can validate to receive that final kind of message from us to say, we're going to send you your stuff, whatever that is. All right, so they get that message, they validate against the BPI, the proof, and of course they're going to get a positive or negative result. So we see at any kind of step here where whenever we have to verify the proof that something agrees with that codified contract logic that's already been agreed upon by the two parties, whenever we get a positive or negative result, that'll tell us right away if that party is acting in a way that we have agreed upon. And if not, then there's no way for us to reach that next state of which we have to go back and then do some kind of like manual reconciliation, like a asynchronized state. Again, just that we're unsynchronized in this case. Now, normally I would ask for questions at this point in time because I've gone over like a large chunk of something, and then I hope it does make sense to like the larger audience. But unfortunately, I'm going to maybe save it to the end, or if I run out of time, then maybe you'll just kind of have to ask me in person, okay? But I feel inside of me right now like the need to be like, questions, questions, questions. Okay. So up until now, we have kind of just assumed that the baseline protocol implementation or instance is there and it's working. And I think if you're really looking for a concrete representation that you can get your hands into and say like, aha, I see this is how a BPI works, I think you really need to look to those implementations. There are plenty of examples in the baseline repo itself, and as you go online and get involved, you run into those examples, and I implore you to dissect more than one to see that the actual implementation between them, really, there is a lot of leeway and flexibility if you're following the actual baseline protocol standard. I guess I can read through this really quick. So the baseline protocol instances or implementations, they're logical constructs shared between transacting counterparties of requesters and providers, and they're implemented on the consensus-controlled state machine. So I think depending on the example, right, in my mind, to say, how much of the BPI, which I tend to see as like a shared state machine, that how much of its functionality is on versus off-chain, and you're trying to consolidate that in your mind of exactly where it's at, I think that is best left for a specific example where we can see, okay, what part is where and what interaction is happening. And that's why I suggest you go look at those specific examples to see what differences have happened in their implementations to compare, what do you think has what advantages or disadvantages and so on and so forth. But for now, we can think of it as just a logical construct that it's implemented on a CCSM, but in reality, a shared state machine where portions will exist on and off chain. Where we've seen in other presentations, there will be like a baseline proxy on top of a connector and so on and so forth. All right, so this is, again, another image from the standard. We have the baseline protocol instance. This is not part of it, it's a CCSM layer. This is just an example of a BPI, how originally it was designed. This gets kind of a bit technical, so I'm not going to go through it all, but we can see that, right, within a BPI, we'll have, let's say, a middleware layer. And that middleware layer may have a workflow section, a messaging protocol section that may exist, outside of the CCSM that may allow for kind of direct messaging within the BPI. Just for example, we'll have some kind of processing layer that may have storage. I encourage you to again to go and look at this. I think this is fairly technical in its representation if you're not a advanced baseliner. But I personally kind of keep this image aside as I'm looking through implementation, see, oh, aha, I see this is where they have done kind of workflows. Maybe this is their middleware layer. And it may not appear exactly as this, all in this single layer, right? But if you can look through and identify, oh, aha, I've seen that they've have the business logic for dealing with workflows here, or the messaging protocols dealing with messaging between two parties, buyers and sellers. It is here. The virtual state machine here, the transaction pool, the storage, so on and so forth. that this can help and lead you to shape that model in your mind of what should a implementation of BPI really look like, and what are the boundaries in shaping that BPI as you do an implementation, right? Okay, so now we're going to zoom out a little higher up. We did the whole, like one-by-one workflow that I really spent a lot of time on, that you guys are probably really tired of, where I did step by step, and now we're going to kind of zoom out. Still the same simple example, right? We have what I call the mid-level architecture. So the mid-level architecture, we're not kind of fully zoomed out yet. We were down at the low level looking at like one by one, right? And now we're kind of zooming up and just saying, okay, well, this is how do I think of all these things kind of together? I saw the buyer, the seller, the BPI. So we have on the left, we have, let's say, a commercial transaction application from buyer to seller. And really, sometimes you could think of this in a concrete implementation as like a baseline proxy and a connector, with some legacy system off over there. And then the seller, same thing, some maybe proxy, a connector, and a legacy system off there. We have the state object, which is not only moving between them, but also through some baseline protocol core stack, that middleware and processing that we've seen, that we've discussed, how to kind of think of that shared state machine. And it's also kind of communicating with these internal APIs through the CCSM abstraction, where we can think of that as kind of housing our BPI contracts, the agreements that we've made between parties that dictate how they interact. How can we buy and sell? What do we need to include for this to move to the next step and be totally synchronized in kind of this trustless environment, and be sure that we have the data integrity on top of low-cost implementation from the legacy systems, okay? As if we can kind of, take this and map it into our minds of what we've learned so far from the low level, like moving back and forth between two parties. This is kind of the next level up of really how you'd start to think about where to implement things at, all those specific things that we abstracted in the last diagram. And then we'll take that and we'll kind of expand it, horizontally outwards to say, well, two parties, yeah, there are some cases, and it's easier to think about two parties. It makes it simplified for us. But, really, as you all know, and I stated in the beginning, is that this is about this large, multi-party, complex problem with enterprises, and it's never going to be that simple, right? Unless you and your friend just want to baseline something between the two of you, which you can totally do. And then so we move out and we say, okay, well, this is really, we're getting more towards real life of, we could have a commercial transaction application from vendor A to party 1, vendor B to party 2, vendor B to party 3, and, we kind of, use your imagination to expand out of, how many different entities could be, working in this BPI as part of a single work group of which the logic of how they interact is dictated, or what they've agreed upon in their own master service agreement, or they could be in separate work groups, as we saw in that original flow diagram, separate work groups that within a single BPI, or even, as we'll see later, maybe multiple BPIs with BPI interoperability, right? Okay, so I'll move on. All right, and so that's where we're at. This is kind of what I call this high-level architecture, right? So this is to complete in your mind the idea of, okay, at the very lowest level, two parties, buyer and seller. The next level up, in the first level, we assume the BPI is doing everything it needs to be able to do. We go to the next level up, and we say, okay, I need to know a little bit more behind the scenes of what this architecture looks like. Well, we're still two parties. We expanded it to 3, but we can see the different levels of kind of architecture. Still very kind of abstract and may not physically be represented as they actually are, but it still helps us. And then we zoom out to the highest level where if you read through the standard, you can see that there are parts of the standard that apply to having multiple BPIs and them interact with each other, all right? We're not going to get heavy into details or anything on this, but this is just to say that the standard does have rules for this to happen, right? That you can, if you abide by the standard, you can have multiple BPIs. Name them Alice, Bob, and Claire, but maybe this is just the person who was the first person in the BPI or in the work group, right? How it's named. And they are all, in this case, communicating by a single state channel on which we may be using possibly multiple CCSMs, okay? So you now have those 3 tiers of understanding of kind of a architecture of what can be done with the baseline protocol. All right, now, that is kind of somewhat the end of the technical of me trying to help you understand the basics, right? To just give you that kind of lift-off to overcome the, that steeper curve of what is baseline, what is this kind of amorphous thing in my mind to help shape it to something that you can imagine and work with within your mind as you're entertaining examples. Okay, so I hope that has helped. Of course, I have to talk about some companies that were inspired by the baseline pattern, right? This is one of the kind of great benefits of having a baseline R&D team is as we think about these implementations, we happen to have many spinouts on ideas that were originally baseline. So we have this was the original question itself that came as a spinoff of how can we enhance current asset diligence practices to allow counterparties to verify asset performance without exposing sensitive data. I'm not sure how deep you have to be in to come to that question itself. It seems like a very, deep in thought, philosophical, financial question, but somebody asked that question, right? And that led to InLabs, so a facilitator and issuer of real-world assets, pools, and DeFis. And of course, if anybody's been paying attention to any of the baseline shows or any time John is on anything at all, this is the question: how can we use the pattern to enable cryptolithography and digital rights management to protect originals for NFTs? That was the question that John was asking, which I think is a little easier to digest than this one of how did you come to that, what thought process led you to that point. And this has led to, of course, treetrunk.io, the first multi-party royalty-bearing NFT marketplace. So we hope to have many more spin-outs. My team and it's not really my team, I'm part of the team, Sonal's team, to shout out to the virtual people. Sonal's team and I, have a lot of stuff we're cooking up, so we're hopeful that in the near future we'll have many different spinouts. Okay, so just a shout out to that. All right, so with that great amount of knowledge that I've transferred to you now, as a new baseliner, let's say, or a middle level baseliner, the advanced ones, you guys already know what you're doing, is how do I contribute to the protocol? Or really, for me, when I originally wrote the slide, it was what do I do next? Where do I go? Or something like that. So I encourage you to actually read the standard. It's a great read. It's perfect, not boring at all. I do encourage you really to read it. Sometimes you're going to have to put it down and pick it up, but definitely read the standard, right? Now, if you only just read the standard, maybe it's difficult to put that to what we've learned today, those models of the architecture. So in addition to reading the standard, look through the existing examples. Read part of the standard. It'll go over, let's say, BPI implementation or one focus of the BPI, and then look through the examples that are online and say, oh, again, I've identified, I've made this connection. Here is how it is in this implementation. Here it is defined in the standard. Here I see it in the diagram. How can I connect these things in my mind? Do I agree that this implementation, in fact, does follow all the things in the standard? And while you're reading the standard, the thing that I've heard and I like to say is the standard is this living, breathing piece of work. No matter what Andreas Freund says and how great he is, I think his intention is for you to question it. And he welcomes this questioning, and so do I. When you're reading the standard, question it, right? When you're looking at implementations, question them. Is this the right way to do this. We are actively and always having standard meetings and revising the standard through all kinds of critiques that people offer, right? So read the standard, look through those examples at the same time. Again, in the original slide, then number 3 was read the standard again, but with a more inquisitive outlook on life. But my business and PR team told me to take that away, and to them I say, too bad. No, all right. And then, view all the existing resources. Go out, reach out to implementations that are not just in the baseline repo. We've seen today here people speaking today, and even ones that are not here today, reach out and see, look at previous baseline shows, demos, technical walkthroughs, and then contribute to the work. So it doesn't mean that you have to be a dev. I'm assuming that a lot of you here are either a dev or business side, but for anybody here online, contributing to the open source work is much more than just being straight technical developer, right? There's a lot more to it. You can be kind of part of the community, help out with the standard itself, help with outreach to get people involved in baseline. There's really many ways, way beyond the scope that I know, that I would say probably only Sonal Patel is aware of in operations. But the first way to start is our nice Get Involved link, okay? So, how do I contribute? That's how you contribute. And to take you to kind of today's convention, the event, what are we doing? It actually started 3 weeks before the event and extends 3 weeks after? Okay. We have the blip bounty hunt. So I'm not sure if most of you are familiar with blips, the baseline improvement proposals, right? And for this event, we have set out a number of different blips that are kind of, we think, interesting and fun. I think there's one about baselining, a lot about baselining cards, which might make you, I don't know, a multi-millionaire with the casinos, probably billionaire. No, millionaire. I don't know. I don't really gamble that much. You guys tell me. And what else do we have? Maybe like a mafia game or calendars. There's all kinds of stuff. So I encourage you to get involved. You can, I've been standing in front of this QR code the whole time. You can find the details here at the baseline blip bounty or scan the QR code. It'll take you through how do you get involved in the blips. My suggestion is join the Discord, read the website. It's a very short list. Once you kind of take a look at all the different blips we've offered, you can find a team, get that team together, and then kind of apply for a grant funds. If you have an idea of how to tackle one of the blips, like, okay, we're going to do this one, then you just go into the repo and apply for the grant funds. So, you can make a little bit of money. Everybody likes money? No? Don't like money? Okay, nobody likes money here. All right. And, if you have more questions about any of this stuff, especially this that we want to get people involved with, you can, talk to me online or Yoav in person or online, okay? And that seems to be the end of my presentation. Okay, I think I'm down to just a minute, so I'm getting the sign that I should wrap things up. I hope that, oh, keep going? Okay, well, I'm personally just going to end it. You guys seem like you might be suffering a little bit, you hardcore baseliners. So we're going to go into a break, and then I believe in about 10 minutes, 5 minutes, 15 minutes, we're going to have the great, I believe it's Anton Mozgovoy is next from Mover, right? So I also want to see what are the Web3 juicy things, right? So 10-minute, 15-minute break. We'll come back in. We'll listen to him. You can go ahead and find me outside if you have any questions regarding the things I've talked about, or if we have anything online, maybe I'll get in the chat, hop in the chat really quick. So thank you guys so much. My name's Keith Salzman.
try to stop myself, but it can't be held. No more excuses. Let's just do this. Feel
All right, everybody, thank you for coming back. I know it's harder and harder to come back from these breaks. So I wanted to make sure that we have some good and fun time, and it's all sunny here, it's all sunny outside, things should look bright. At the very beginning, Samrat and then Keith said that Baseline community is very open and it's very welcoming. I think that's, we are an example because nobody invited us, but we just came in and we started doing things. What I'm going to talk today about is what we do and how from basically being a card company, being Web3 sort of heavy on experiments company, we ended up doing something with Baseline, and specifically Baseledger, which is again the implementation of baselining. When I was building up this presentation, I thought that there's actually just one slide that's boring. Our lawyer said that's actually the only slide that's exciting. It's this one. So yeah, that's just a little bit of disclaimer. So everything that I'm going to show you guys here is all just pure information, so it's all for your reference. So I know some of you aping here a bit too hard, so just to make sure that we say it. We love QR codes, so I'm not sure if you guys can scan it, but whoever's going to be watching it afterwards. Instead of talking about myself, you can just see what kind of stupid things I say in Twitter. So if you are interested in that, just join. What we're going to talk about today is, how many of you guys know, well, you obviously know Unibright, but how many of you guys hold UBT tokens? Okay, I see a few hands. All right, okay. So what we're going to talk about today a bit is what do we actually do? What do we do with UBT staking? And that's also part of the exciting Web3 stuff. So how do we make things permissionless? We're going to talk about experimental stuff, which is, again, a very, it might be the weirdest use case. I don't know what's the word with the use case here, for baselining stuff that we are specifically building and we're using. And we're going to talk a bit more about what comes next for us. First question, what do we do? Well, Mover is a set of different tools. So basically, it's just a combination of things all combined together to do a very specific job. Is how do we bring this Web 2 experience of saving and spending your money into the Web 3? So the key important thing here is everything that we do in Mover is permissionless. And that's pretty important as we're going to come back to the UBT staking, for example. It's just one of the products that we do. So let's quickly dive in. What do we have? So we have Savings Plus, which is an omni-chain savings. What is omni-chain is basically when you don't care on what chain you are. You can be on ETH, you can be on Polygon, you can be on Phantom, whatever you are. And the transaction that you make on that chain actually triggers something that happens on another chain. So for instance, your savings or yield strategy can be on another network and you don't even experience it, which is good because if you actually try doing things multi-chain, it's terrible. It's absolutely disgusting. So hopefully we make it better. We also have a thing, I love this piggy bank thing. We also have a cool technology for gasless on-chain transactions, again, permissionless. And that's why it's a smart thing because, you don't want to pay gas, fees, right, every time. Somebody still has to do that, but, not you. And then we also have the crypto debit card. There's a lot of crypto debit card products. I think that we are the craziest people out there to try to push the permissionless and basically decentralized stuff as far as possible. So again, for you guys to understand, anything to do with fiat is regulated. It's licensed. But then there's a very thin line of how far you can push it and stay, be legal, compliant with things, and yet still offer, cool Web3 stuff. So let's talk about staking. And some of you guys also have UBT tokens, which is a pretty important thing. Basically, a UBT is a token that's used for staking in the Baseledger. Baseledger is one of the implementations of Baseline. UBT token lives on Ethereum. Baseledger is a separate blockchain. And there's an entire mechanism of how you, as a UBT holder, can extract the value of basically the Baseledger working. So in simple words, right? So we apes get the reward. So how can we do that? Well, right now, what we created is the only permissionless, open, and non-custodial proxy staking solution for both stakers and validators. So as we, typically, in a typical project, how does the staking look like? Well, you just deposit your tokens into some smart contract. It prints some rewards, every block or whatever, and that's pretty much it. So as simple as that. There are more complicated models. There's, if you guys know, let's say something like V models, where you time lock things, and then based on that, you get different rights, whatever, not getting into that thing. And here, it's very different, because the tokens that you stake on Ethereum actually just represent the staking power on the Baseledger. And then the node validators that do things so on Baseledger, they are the ones who earn the rewards. And then they have to share basically with the ones who provide that staking power. So what we do, in simple words, we let people who own UBT tokens connect with the node validators who actually do have nodes running up and doing things. And we connect them in a permissionless way, allowing people who stake UBT to earn a portion of those rewards, and allowing the node providers to get more staking power so that they can earn more rewards. So in the end, everybody's happy, and we're happy if you're happy. That's what they told me to say. So we have more than 2 million UBTs staked, and it's a lot of different wallets. It's a lot of different people. We're going to talk about why it's cool in a second, because there's a very specific limitation on the Baseledger. What it means is that in order to efficiently generate rewards, you have to have 1 million UBT tokens. So if you have more than 1 million tokens, you're not getting more rewards. You're not benefiting. So basically, it's all about being efficient. So what it means is that now that we have more than 2 million UBT tokens, here comes the cool thing about, well, how many node validators we can actually help and provide more rewards or being more efficient. By the way, there's already a huge lineup. So the reason why I asked if you have UBT tokens is not because I genuinely care if you have it, but I generally care if you can stake it on us, because we have a lot of validators in the queue. So the more UBT tokens we have, the more rewards everybody gets. Let's take a look at how it actually works. So this is actually a very, very cool chart. I animated it. To be honest, I didn't, but it's different slides and it looks cool. How many of you guys have coded a smart contract? I mean, like a simple hello type thing. Oh, a lot. Okay. Well, that's fantastic. I mean, all right. So this is the part for the rest of the people. Basically, what you can do with Mover is you can do two things, only two things, right? If we're talking about UBT staking. You can only deposit your tokens, and you can withdraw. And you can withdraw, well, either the same amount of tokens if you have not earned any rewards, or you can claim more if you earn some. So, as simple as that, as cool as that, just two functions. But then what actually happens underneath is we have what's so-called sub-pools. So here comes the very interesting solution about optimizing the rewards. And it's also important because in order for us to make sure that we provide efficient service, and it's still permissionless, we have to make sure that all of the node sub-pools, we didn't come up with cool name for that thing, sorry about that, they all share the same state. So basically, it doesn't matter how many millions of UBT tokens we get. We can create as many sub-pools as we need, and we can always share or rebalance between those different pools because people can withdraw, people can deposit. So a very interesting concept about this is that you, as a user, you deposit into the pool, which then rebalances into the different sub-pools. But in the end, you can always withdraw your tokens back. It doesn't matter because your tokens do not go to the specific node, but rather the total accumulated amount of tokens go to the specific node pool. So now that we have the different sub-pools and they're filled with tokens, we let the node validators to be delegated with basically this staking power. So what it means, in fact, is that we say that a specific node has the specific amount of UBT tokens assigned to it. And then when the node operates, it earns the rewards. The cool thing about this is that the rewards do not go to the node validator. So in a typical model, let's say Ethereum node validator. So what happens is that you have your node, it's running, you earn the rewards. And when you are earning the rewards, you are the only sole owner of the rewards. And here, the model is that all of the rewards that are earned through our subpools go to the specific contract, which receives all the rewards and calculates all of the rewards for both the stakers and for the node validators. So the very simple thing, the very simple solution created out of basically the existing structure of, let's say, staking of a specific token in the Baseledger model, created a very, very interesting, a very elegant solution of how we can provide, put it this way, how we can provide compounded rewards. Typically, and I'm going to go into it, and that's also a reason why I put the disclaimer at the very beginning. If you claim your rewards, so you've earned something, cool, you've earned some crypto. Well, now it's a taxable event because you claim your rewards, so now you own them. So not good. Now in this model, you as the user, you do not get to claim the rewards until you leave the pool, and then you decide when you want to leave the pool. So the reason why this model, and this is just just an example of what we do. This is just one of the products that we do, which is related again to Baseledger, which we're going to go in a bit. We created a very cool thing which has no lockups, no need to trust a validator. We have the cheapest deposit and withdrawal transaction. How many of you guys know, let's say, or have a slight, how's better say, experience with calculating gas cost of transactions on ETH? You guys do. Okay, so if you guys remember, I'll give a reference for everybody. The cheapest transaction that you can do as a user on Ethereum network is sending raw ETH. So basically sending ETH from one wallet to another wallet. And it costs 21,000 GWay. So that's the cheapest one you can get. If you, have you guys ever used something like, let's say, Aave? So you guys, same people, okay. Right, so if you use that, then you know that any, let's say, transaction like providing collateral or borrowing money or repaying your debt costs a lot of gas, like at least 400,000 GWay. So see the comparison, 21,000, 400,000. Now, for us, in our case, depositing and withdrawing costs only from 120,000 to 140,000 deposit withdrawal transaction. So this is the cheapest deposit withdrawal you can get in the staking model on Ethereum. Pretty cool. But what it means is that, as I said, the reason why it's a tax-friendly staking for UBT specifically, because you as a node validator and you as a staker, you do not get to receive your rewards up until you actually claim them. So that's a very interesting model, which allows us to compound them by basically recycling the rewards. So as rewards are being harvested, we put them back into the pool, and then the pool back, rebalances back to the specific node. And that rebalancing, or the constant harvesting and sort of like looping the rewards, provides the difference between, have you ever seen this bank signs that tell you, okay, so our APY is 0.01% or something like that, right? Have you ever seen the same sort of posters, but they say, okay, our APR is slightly better, slightly bigger. So there's a difference between APY and APR. APY is like a naked kind of rewards, and APR is compounded. So basically, theoretically, what if you compound the rewards, how much more you can get? So this is the same thing of there's a native APY, but then what we do is really focus on APR because of the compounding effect. Okay, cool. Now, if you scan this thing, and that's probably more for online folks, so I'm looking at you guys, scan this now. So right now, UBT staking is only live on Ethereum, but we do, as I said, we do try to focus on omni-chain stuff. I'm going to talk about it in a bit. But basically what we will allow you guys to do is to stake your UBT tokens whatever they are. So any chain, anything, and obviously it's going to be much more efficient. So that's just a little bit of the alpha there. Okay, so let's talk about omni-chain. How many of you guys have tried to do a transaction on at least two networks? So let's say ETH and Polygon. Same people, I would expect you guys. Okay, there you go, new person. So the next time I ask you a question, just raise your hand. It's mostly going to be you. Anyways, multi-chain life is very, very hard. So you gotta have your wallet, and then your wallet has to point to the RPC that goes to a specific network. And if it's a new network and the website has a bad UX. You have to manually find out what the RPC connection is, what the points are gonna fill it out, especially it's the first thing. And then you figure out that if you want to do a transaction on a new network, it turns out that you have to have gas money. So then you gotta look into the faucet. Okay, where do I get this gas money? And then depending on the network, you either get it or you don't. So you have all this like different experience in different problems. And then once you find the gas money, that's the most important thing. You have to find the bridge, and then you figure out that you also have to pay the bridge, to bridge things, and then you have to actually do whatever you want to do. So let's say swap the tokens. So you found this new token on some new network. It's very exciting. You want to get into it, and then you have to do all these different things just to get to the token. We want to change this thing. So that's why what we do is we have a network of proxy contracts, and this is also the same mechanism as I explained earlier about the staking pools. Basically, what we do is that where we're heading towards to, and then with one of the products that's coming up live very, very soon, what you're able to do is that you're able to come from the network A or transaction A and do whatever you need to do on either on the same network or in a different network without actually touching it. So when it comes to like financial products or the Web 2 that we all don't like, the experience of using it is very seamless. But the biggest problem of having the Web 3 is that yes, it's new, it's cool, but the experience is so bad and it's hard that it's sort of like you ask yourself like why do you even use it? I mean, how many of you guys have had this thought? It's like, okay, the coffee downstairs is cost like €3. That's too expensive. I'm not going to pay €3 for a coffee. But then you guys ape into like an NFT mint, which worth like €200, and then it's a failed transaction, and then you got to pay more money, and it's somehow fine. No, it's not. So that's basically why what we do is trying to build all these different products that make your life easier on a daily basis. Of course, if you are into crypto. And that's what I wanted to say, right? So this convenience of doing things in a permissionless way comes with a cost. So right now the cost is that basically inconvenience. It's hard. It's very bad. I don't know why, but maybe because it actually feels like the internet of 90s. Most of the websites in crypto do actually have this pixelated 90s kind of feel. Kind of looks as it works, right? So trying to change that. We're doing that. And that's, yay, looks beautiful. And that's basically when it comes to the tokens and stuff. And please remember the disclaimer at the very beginning. Also remember, a note, make sure that you say that at this thing. So I'm not going to say much, but basically in order to create this new economy of trying to move things around different networks, or letting people to enable this possibility. For example, to give you one of the interesting topics of how this can be used, let's say we have a crypto debit card. The way crypto debit cards work is very simple. You have some crypto, and then you have an IBAN, for instance, right? As we're here in Europe, and then you need to settle your crypto, which basically means sell your crypto and then credit your IBAN with whatever fiat money there is. Okay, how many of you guys here have crypto debit cards or used? That's a lot more. Okay, how limited you are, in a sense, how many assets can you swap, right? So to top up your card. What is it? Let's say we're talking about ETH-based world. So it's ETH, USDT, USDC, probably DAI, what else, right? So, you're pretty limited. And it depends on the, crypto debit card provider. You're basically either limited to their network, to sort of like their world where they want to keep you, or you're just limited overall with the number of assets, right, you can use. So what I mean is typically, what do you use to top up your crypto debit card? Like ETH, right, or USDT. Or let's say you hold ETH and then you swap it and then you use it for, to pay up your bills offline. What we do is, since we try to push things, again, as I said, as far as possible. So for instance, we have a swap mesh. So all of a sudden, any liquid token on basically ETH or any other L2 becomes swappable. So a very simple thing, but now you can, whatever ape token that you have, you can use it for the top up. But what it also allows, for instance, right, let's say you live on Avalanche, let's say you live on whatever new network, there's going to be tons of new networks. And especially as more ZK stuff comes in, there's going to be so many new different implementations. But in the end, whatever you choose, again, you still come back to very specific problems that you have as a user. Right? So we're not talking from the business perspective, we're talking about the user perspective. And in the end, it all revolves around the money. So that's basically what we have help doing. So now, finally, getting back to our thing. So how the hell on earth we have something to do with baselining? Well, so that's what I said at the very beginning. We try to push things, being permissionless as far as possible. Now, unfortunately, the governments do not let us do that fully. What it means is that, for instance, something like a debit card is a regulated, permissioned product. So basically, in order to offer services to the users, you have to be licensed, you have to be compliant, you have to follow specific rules. For instance, just the smallest one, you have to follow the GDPR rules. Everybody knows the GDPR. Everybody knows that there's huge fines if you do not follow it. So how on earth can you provide, for instance, this service, but still, what does it even mean to push the permission stuff further? What does it even mean? If it's still a regulated product, there's nothing that you can talk about, or something like zero knowledge proof. How is it even possible? Well, let's take a look. So the way the mover works is mover itself is a completely permissioned product. So what it means is that mover knows nothing about you. Mover stores nothing about you. So mover doesn't fall under even the personal data protection. Why? Because it doesn't know anything about you. But then how does mover connect you with the card issuer and then all the information about your card that you offered? So the way we do it currently, and then again just trying to explain it to you, is, for instance, when you're signing up or when you're coming back, and we don't know if you're signing up or coming back, we have a very simple way of basically remembering you as a user. So for example, you have the email, and then you have your wallet address. And then the combination of those things create a hash. So, gibberish data that means nothing. So it cannot be reversed. What it means is that if you have the hash, which is, can be a public thing, you cannot tell what your email is. So it's a one-way street. But by signing, right, so when you create the hash with a specific address and specific email, you create this unique thing. So okay, so now at this step, we know that there's a unique identifier. So when we see this identifier the next time, the first time, the second time, we know it's either the returning user or not. Now that we have this hash, we need to share this hash with the card issuer. So let's say the card issuer is the licensed entity. So that's the one that's actually sponsoring basically the license to make sure that the card is issued under a specific name. And what they need to know is, okay, well, we've got Anton, and then here's the identifier, the unique identifier. Call it an ID for Anton. So Anton has an information. Anton has a specific IBAN. Here's the Anton's information, and then here's Anton's hash. Now, when you come to us, when we create this hash, we send this hash to the card issuer. At this point, we don't know who you are, what you are. We have zero information about you. And we need to share this information with the card issuer, so the hash, and ask them, okay, well, who's this, right? So is this the new guy? Is this the existing guy? Like, who's this customer? And then they tell us that, okay, well, it's a specific user, right? Or it's a new user. And then you get into the new problem. Okay, well, how do I make it seamless for my existing customers? As I said 5 minutes ago, Web3 feels like 90s because of this basically bad user experience. You have to overcome all of these differences or difficulties just to perform simple things that exist like off blockchain. So now we get into all these different hoops, and since we don't know whether the user is new or existing or not, we have to follow through all this process. Now here comes the baselining. It just makes our life easier. That's the answer. But basically, what happens is you sign up, so you create your account under whatever, again, local regulations are with the card issuer. And again, mover has zero participation in that process. We know nothing about you. But when the card issuer creates an account, they're also just dropping a proof. So poof, they just drop the proof. So there's some gibberish data, so a hash again, which can live on a public ledger. We don't care because basically this data is gibberish for everybody out there. And the next time that you as a user, you come back to us, or maybe you are a new user, we don't know. But then this entire process of you, signing up, how do you access dApps? So decentralized applications. How many of you guys have ever used a dApp before in your life? A lot. OK, so you know that in order to authenticate into the dApp, you need to authenticate with your wallet. There's many different wallets, but the beauty of the dApps is you have a freedom of having your own wallet. So it can be a ledger, it can be a MetaMask, it can be a Trust wallet, it can be whatever it is. Basically, as long as there's a Web3 provider, then you can connect any wallet. And then you have the freedom now to store the money where you want. So you don't need to store the money in an exchange account. You don't need to store the money in, whatever custodial wallet solution there is. You can keep the money where you want to keep them. But then when you need to top up your card, you're just coming to us. You're connecting with your wallet, and you're basically saying, OK, well, it's me. Here's my wallet. And then just by that hash, we can actually check the Baseledger, and we can see that, now we know who you are. So now we can request the specific information about the user. So this is a very tiny thing, solving a very non-existing problem we created just because we want to do things differently. So it's a non-existing problem, but it actually gives you a sense and a feeling that baselining can be implemented into very different things. And this is just one of the examples of how we used it. So now what comes next? As I said earlier, we do a lot of different, we experiment with a lot of things. We experiment with NFTs. We experiment with DeFi. We experiment with ZK stuff. What comes next? Sorry, that's the wrong slide. I don't know why it is. We call this beta card. To be honest, when I was thinking about this name, Zuckerberg didn't rename Facebook. So I'm not sure if we should sue them. I don't know. Maybe they will sue us. But it's called MetaCard. So where we're going towards to, if now you know that we try to create things permissionlessly, we try to push this decentralization as far as possible. We are hard advocates on privacy and how to push the privacy. We want to make sure that now everybody, like in all of the metaverses, everybody else, whatever network it is, whatever chain it is, we want to make sure that you can have your card and you can pay with it like in the real world. So that's the idea of the MetaCard. In a simple terms, basically what we're building and working on is a set of extendable ERC-71 contracts that live on different chains, connect to our infrastructure, and allow you doing very cool things. That for instance, the ZK stuff we talked earlier. We're also working on the self-repaying things. How many of you guys have heard the name Alchemix? Okay. I'll explain you the idea. Let's say you take a loan in your bank. So let's say you have some money in your bank account and you use that as a collateral, and now you take a loan from your bank for whatever needs, the business, personal stuff. And then what happens afterwards is that you just accumulate the fees, right? From the loan that you took. So over the time, the fees accumulate, more and more, and you just have to pay more and more until you pay out. You know that credit cards, if you just pay the suggested minimum amount on your credit card, you will literally never pay off your debt. So it's designed like that because, well, that's the way to make money on you. Now, crypto is over-collateralized. So what it means is that if you want to take a loan in crypto, you have to provide a collateral which is larger, so bigger, than the amount of the crypto that you want to take in. But what it also gives us is that we now have this massive amount of collateral sitting there and doing nothing, right? So what happens if you put that into the yield strategies? What happens if that collateral now generates yield for you? What you're getting is you are getting a self-repaying things. So imagine this: you have a bunch of crypto. You don't want to spend it, but you need to pay things offline, right? So you need to have something on your debit card. And then what happens there is what you can do is you can use your crypto as a collateral and take a borrow. So you borrow some credit in, let's say, stable coins. So use those stable coins on your card, buy things, pay rent, etc. But then the collateral that you had there, that you deposited, is now actually generating yield for you. So what happens is that, yes, you have an interest on your credit, but you also have an interest on your collateral, which is making you money. And then if the difference is positive, so if the interest rate on your loan is lower than the yield on the collateral that you have, you are actually in profit. So over the time, you're literally slowly, bit by bit, but repaying your loan. So imagine this. It's like a supercharged credit card. So it's like a credit card that you use, and over the time, it repays itself. I mean, that's sounds like infinite money, right? But it just gives you the idea of how far we push things. So for instance, this is what comes next when answering this question. I think that's it, and yeah, that's it. But hopefully, what I really wanted, for you to give you guys today is to give you the perception that number one, crypto is not boring. Number two, there can be complicated things, and we can make them sound very complicated, very cool. But in the end, all of these complicated things are here to solve simple things that we use on the daily basis. We use human beings on the personal level. Number three is I would say doesn't matter how crazy the idea sounds. For instance, like why would you have a crypto debit card that you can access through the service that doesn't have the information about you, and just because it doesn't have the information about you or on you, you have to go through all these different hoops so that they can prove that they don't have any information on you. Like, how the hell on earth would this be a viable business model, right, in the real world? But because we live in the age, and as I said at the very beginning, we're early. We have this time, we have the opportunity now to innovate, to change things. So that's what I hope to bring you guys today, that you're here for the EthDevConnect. You're here to hear about some crazy, stupid idea so that okay, well, that's so stupid, I'm definitely not going to do it. So, or you're going to hear in something like, what, I can do it better. And this is exactly what I'm challenging you guys today. Whatever you hear, whatever application it is, whether that's enterprise focused, whether that's retail focused, whether that's personal things focused, whether that's gaming focused, NFTs, whatever it is. But there's so many unsolved and untapped opportunities that we can actually try and work and look at the different angle. So I think that's pretty much it. And obviously, if you guys have any questions, we have time, so we can talk about it now. If you want to ask me about something that I don't know, don't ask me those questions. How do you know? Zero knowledge proofs. So baseline it first. I'll check it and then come back to you. That's it. Thank you very much. Cool. No questions. I love it.
I got a question. Can you verify when you get the debit card? Do you get the debit card? Do you get the debit card without showing KYC to anyone, or do you just show the KYC to the card provider? Can you elaborate a little bit on that?
Yeah. So unfortunately, the world we live in, you have to KYC, to have this kind of service. But there's a difference between the mandatory stuff and I would say unnecessary stuff. What I mean by that is there has to be, a card provider has to have the KYC information on you, so they have to store it. But then there's a big difference of who has access to that information and who stores it and how. And there's specific entities that are regulated, and that's what they do, right? So they provide KYC services. So that's how they receive your documents. They check it against government databases. They check if you're a good guy or a bad guy, or if you are who you say you are. But then all we need to know is that it's a green light or it's a red light. And we do not need to know, who you are, what you are. So the KYC provider will always have that information about you. That's what it is. Again, current regulations. I don't think they will ever change or go back. But again, so they hold it. They have it. If there's any situations, then obviously they can provide it to the necessary regulator, whatever it is. So always pay your taxes. Make sure you do that. Yeah.
I have one question about this loaning the money. Let's say when I'm now selling my crypto, this is like taxable event, right? I have to pay my taxes. When I over collateralize my loan and then use this money to spend, I'm actually not spending my money. I just have a loan, so there is no tax, right? Do I?
You're a very smart man. The way I'm gonna answer this is, first of all, I'm not your lawyer. Everything I say is nonsense. So please consult with a professional lawyer. But I have heard the rumors that if you spend debt money, then maybe it's not taxable. Okay. But again, I don't know.
I think it works like that in the States.
Should work. I makes sense.
I think it does, yeah.
Actually, you have a loan.
Yes, please go ahead.
Simple question: how do you plan to monetize this as part of your, as part of your token, and that kind of?
Yeah, that's a cool one. As they say, right? So when there's no fee for the product, right, it means that you are the product. So this is actually a good thing about crypto because everything has a fee. Whatever you want to do, Vitalik even made the fees for the network, right? He doesn't let us do free things. Basically, offering these cool things, something that, for instance, nobody can provide right now. For example, do you have a crypto debit card that can offer you all this like swapping and exchanging and everything? Let's say something like an Avalanche, and you do whatever things you need to do on that network, and then whenever you need to spend money offline, boop, you just natively kind of top up your card and do it. And then that process of swapping can involve fees. So if we decide to turn on the fees, then basically you'll just pay the fee to, let's say, do this kind of stuff. Because otherwise, what you'll have to do, you can still solve this problem now, right? So don't get me wrong. But what you'll have to do now, let's say, in my example, Avalanche. So, all right, so what you do now, because you'll have to bridge it. So let's say whatever token you have to swap it now to the major ones that have liquidity for bridging. So now you swap your token to, let's say, ETH, right? Avalanche version, or USDC. Then you bridge it, so you pay the fee. Once you bridged it, then you need to send it to an exchange, or you need to send it to whatever custodial wallet that your service has. So it's also the fee. And then once you send it there, it's also, how do they make money? Well, off the exchanges, right? So then when they settle it, they also need to pay the fee. And then who settles it? Because again, a card provider, let's say, is not a settler of the transaction. So settling is that legal process of actually selling your crypto for fiat and then crediting the fiat to a specific either correspondent account or a specific IBAN of the user. So they also need to make the fees. So every step of that process is where you pay fees. So why not pay that fee at the very beginning? Because again, typically, crypto debit cards they have what? They have Bitcoin, so they have like Litecoin, all that kind of stuff. But if it's ETH related, it's only ETH related. I think there's only 2 other providers that now support Polygon. But then I have never heard of anybody, let's say, doing anything like for Optimism or for Arbitrum or for Avalanche or for whatever new network there's going to be. And there's going to be many new like EVM networks out there in the future. So. Cool. Thank you very much, guys. I appreciate it. Hello, Mom.
So we'll have our last speaker today in about 5 minutes. We'll take a short 5-minute break, and then we'll have Harry Behrens on, a co-founder Chairman, CTO of bloXmove. So thank you guys. Be back in 5 minutes, okay?
Well, hi. So I'm Harry. I'm director and CTO of a company called Power and Mobility, and we're building a platform called bloXmove. And before I came, the whole slide set's fairly big. So I was going to tell you a lot about how we apply decentralized technologies to mobility and also to what speaks to our company name on integrating the power sector and the mobility sector by the sheer fact that a vehicle, an electric vehicle, is not only a piece of the mobility sector anymore, but by nature of its battery, it becomes part of the power grid, and that opens amazing opportunities to basically revolutionize the way of mobility, to make it net zero, to make it carbon neutral. So in a nutshell, I was going to speak a lot about the purpose of our company. I decided to pivot a little bit after hearing the very interesting presentation by the colleague from ConsenSys. So I decided a little bit to focus more on the protocol layers that we use in order to address the purpose. And then hopefully I will still have some time in the end. So our basic business proposition is we want to make mobility plus the related services from the power sector, charging, etc., also grid balancing, which is a big problem if you have networks with renewable energy, to make that decentralized, which means cut out the intermediary whose only benefit in this world is to basically be somebody that both parties trust. And the user journey that should ultimately come out of this, and it's a user journey, and it's also a business journey because the two belong to each other, is very simple. For the user journey, the best example, and that's the benchmark for all use of services across a wide ecosystem, is roaming. Each of you has a mobile phone, each of you has a SIM card, I'm just positing that, and you don't even think about when you go from country to country, there's a service provider picking you up, delivering you the service. It's completely seamless, you don't know about it, and nobody chases you for the money. It's all handled in the background by B2B. That is how services should be consumed, roamed. You get onboarded once, whoever onboarded you keeps the customer relationship, which is important. You don't want some big aggregator coming in and swallowing the relationship, twisting the whole economic balance and extracting 20% of revenue from you. You want to keep your customer in doing that. And everybody should be keeping their customer. And on the backside of it, on delivering this service, what you want is you get your money because you're delivering the service, you don't know this customer, so you want to get your money, and this being low margin business, you can't have manual operations. This needs to be totally automated. So that's the basic vision behind this. Okay, so there's more than 2,000 providers alone in Europe, this is not even worldwide, alone in Europe being active in the mobility industry. And mobility is essentially, I'm not sure how you're moving in Amsterdam, so mobility nowadays I used to be the generation still, my father more so, you buy a car and that's the mobility, and you buy the car in cash, and that's about the end of mobility. Maybe a train ride every now and then. Now this is a very fragmented story. So in Amsterdam, you got, I don't know how many mobility operators, Dion might know, my guess is 10 to 15, and in every city I go to, it's the same. So, and it's very hard for these companies to achieve scale unless they are Uber or MyTaxi, by which time they have accumulated an inordinate amount of market power and basically become rent-extracting monopolies, because it's very low margin business. Just that's something to understand. Charging power and delivering mobility service is not micro-transactions, it's mini-transactions, and it's very low margin. Public transport is the only countries in the world that are profitable. There is Hong Kong and Japan. Nobody else has ever managed to be profitable in public transport. It's government subsidized. And the mobility operators that you see out there, they're basically burning Silicon Valley money, but they're not profitable. So we are now, whoops, go back here. So, and we try to address this by basically providing a network based on decentralized technologies that operators can get together and form something, and that's about the end of the pitch here, that we compare to how the Star Alliance works. What's the Star Alliance? I used to be a frequent traveler, not lately anymore, But it's an alliance of airlines, and they are fierce competitors. So United Airlines is in there, Lufthansa is in there, and Air China is in there. That's the example I always do. So outside of their respective home markets, they're fierce competitors. But they happily and friendlily get together in the Star Alliance, allowing what? Each one of them, and I'll start with Lufthansa, each one of them can sell their customer a ticket. So Lufthansa is selling me a ticket, where I buy a ticket from Frankfurt to New York, to Los Angeles, and from Los Angeles to Shanghai. I will get this ticket labeled Lufthansa with a Lufthansa flight code, LH whatever, and the Lufthansa keeps the customer, sells me a product that goes vastly beyond the assets that they have, vastly beyond the landing rights, but they sell it to me as if they sold it. Now, why do these companies, two companies, do that? Lufthansa is fairly easy, as I just said. They keep the customer, and they're selling me something that's beyond their assets. Beautiful, right? They've just widened their products without deepening their balance sheet and without needing the assets for this. Beautiful. Now, why does United Airlines do this? Well, that's simple as well, right? The seat that I'm going to be sitting on, flying from New York to LA, is going to be a seat that they did not sell through their premium sales channel. It's going to be a seat that was vacant. So they are now filling that vacant seat. They're getting utilization, which is core in the business, at zero cost of acquisition. That's beautiful. That's essentially 100% profit. Plus, the beauty of it is United Airlines, keeping their own customer, keeping their own channels, can do the very same thing. So I might be sitting in an airplane next to John Doe, and John Doe is doing the same trips that I'm doing. He's holding a United Airlines ticket in his hand, and I'm holding a Lufthansa ticket in my hand. All right, that's basically what we do based on decentralized technologies. And then now comes the clue here. You need to differentiate when you do decentralized business, which is cryptographic in nature, and partly decentralized. And I'll get to the partly decentralized. There is very often the misconception that blockchain is perfect. Especially, you hear all these dreamers coming along, supply chain, blockchain can save supply chain. Well, supply chain is a physical problem, people. It's a problem of ascertaining business facts, cobalt mines, whatever it may be, that the cobalt doesn't get switched, that whatever you're stating to be a fact is truly a fact, because once you put it on a blockchain, it becomes immutable. Blockchain is a perfect record, but it suffers from the bullshit in, bullshit out problem. I can state the moon's a green cheese, and I just sold it to Diane, and if I put that on the blockchain, it stays on the blockchain, it doesn't make it true. So how do you address physical truth, business truth? Well, very simple. You need identities, real-world identities, in order to be able to do that. So let's get back to the very basic nature of every single business transaction you will ever do, online or not. How does it work? And it gets best described by the simplest form of achieving it. Harry offers Dayon, hey Dayon, you can have my car over the weekend for 100 euros and you fill her up when you give it back. Is that okay with you, Dayon? Dayon says yes. We shake hands, and all we need is a witness in the room. That is a legal contract we can both take to court. That's a valid contract. And everything is settled in there. So now let's translate that into digital, into decentralized, into the crypto world. There's a new set of beautiful protocols out there. They're called decentralized identifiers. A DID is essentially very similar to a URL. It's a URI to be totally precise, but that's hair splitting. So it's very similar to a URL, which you give to parties as an identity. So you can give an identity to a person that's obvious. You can give an identity to a company that's almost obvious. And you can give, and that's where the huge promise lies, you can give identities to the billions and gazillions of devices out there. And now you have an identity. An identity is always associated with a private key, public key pair. It can be anchored on a chain, but most importantly, it is blockchain agnostic. So it lives outside of any blockchain, outside of any implementation space. And what you can then do is identities can sign certain credentials. They can issue a credential, and they can accept a credential, and they can countersign it. And if you look at the example I just gave you, which is based on consent agreement, what you need here is very simple. Now, digitally speaking, Harry with his DID Harry Company with his DID, presents an offer to Dion, digitally signed, so Harry did sign this. And Dion, with the terms and conditions that are in part of what Dion now sees, countersigns it. Both of the identities, and this is where in business world at least, the mover guy also said it, we need KYC. It's not purely decentralized, it cannot be, because governments do not accept perfect decentralization. Each one of the identities will need to have been approved by a respective authorized party. Could be KYC, could be the bank, could be the government. In terms of a company, could be done in Bradstreet, could be the LEI, the legal enterprise identifier or the like. And for devices, there's other organizations. For cars, it's the Vehicle Registration Authority that will take a VIN, and if you give it a DID, will marry that in what's called in cryptography in a ceremony, which is always needed, which is always physical, by the way. KYC is nothing else but the bridging of the gap between the physical world and the digital world. That's called a ceremony in cryptography, and it is needed to establish the physical identity. And only once you have established the physical identity and connected it to the public key, to which you hold the private key, can you now conduct digital signatures, digital transactions, but they can be traced back to your physical identity. So we solved the green cheese problem, which means how do we now need to conduct business? It's fairly easy. All I need, and it's a very primitive form of what the baseline protocol does at a much more sophisticated level, which is why we slowly in our journey are converging into this direction. All you need is very simple. We need to agree on the business fact, on the terms and conditions. This gets signed, and the blockchain acts as the notary, simply as the timestamp and the witness. That's pretty much most of what the blockchain does at that point in time. It just bears witness to these, however they are documents, legally speaking, to this consent agreement, which is signed and countersigned, which constitutes a legal document. It can be printed out, and you can basically look at, okay, what signature algorithms are these guys using? You get yourself the library for that. Okay, this DID, that DID needs to have a credential from a trust authority, which ultimately is originating from whoever the government says it must originate from. And so I have a signature here from a DID that claims to be Harry. Harry has been KYC'd and so on. So this is a business fact. Then you put this business fact on the chain, and you don't need this so-called smart contract layer, which I have never seen realized yet. I have yet to see a smart contract. There's a lot of software on Ledger out there. Nobody has ever done Ricardian contracts legally valid. But it solved, using these DID layers solves that problem. And you only need the chain then to be witness to that. Then you need a small smart contracting layer that basically counts the units that are being consumed, especially if you have a fully automated vehicle with a built-in telematic device that then has an identity, so it's called a hardware wallet in this case, which is basically a hardware wallet is nothing else but whatever you hold in your mobile phone put into a device such as a vehicle or such as a charging station, which then can send you data and sign that data with the identity given to that device. So you can always trace it back to that device and no other, assuming the ceremony by which the identity was given has an unbroken chain of custody and an unbroken chain of proof. So this DID layer is highly, highly relevant in making something like blockchain useful in an enterprise level. Because in an enterprise level, ultimately everything, and this is also something which is very important for pure blockchain people to understand. Blockchain is very much the opposite of accounting. Blockchain is based on the concept of possession. I hold it, it's mine. No crawling back, that's it. I've transferred it, that's it. The chain takes care of that. Business is not based on the concept of possession. Business is based on the concept of ownership. And I'll explain why that is very, very important. But first of all, what it means is, for every monetary transactions, UTXO, whatever, which goes from A to B, you do need to have a business transaction with an invoice being on the other side, and the two have to be linked. Very simple, which makes it very, very clear. I pick one of you guys, let's assume I can afford it. Give me your bank account number, and I transfer $500,000 to your bank account. Do you think you have money now? No. You have a hell of a lot of a headache. Because you will never, ever be able to touch that money. People will come knocking, will ask you, where's that money come from? If you say, I don't know, What? You have $500,000 on your account, you tell me you don't know? You better come with us. Unpleasant $1,000 and get them out of your system, and thank God that and hope that this doesn't happen again. That shows you how quintessentially blockchain in this world. You cannot transfer money. You need proof of transaction. And that's how I count my money, and that's how I report my money. That is real money, and anything else is not. So it speaks to the concept of ownership. Ownership is what is legally recognized as being yours. Possession is what simply happens to be in your bank account. Those $500,000, you are the possessor of them. Don't be happy about that. So from a protocol perspective and a business perspective, this is highly important, and this is what we base our whole platform on. So there's two layers now of protocols that come together, and this applies to any business. You got this whole DID, so identities, credentials, digital signatures, always connected to an identity that has been verified, so you can relate to it through KYC, through KYB, know your business, or through know your device, so you can always trace it back. Then those parties agree on something, which happens by digital signatures. This then gets witnessed, timestamped, notarized, attested, baselined, you name it. Then in a fully automated world, you count the units that have been delivered. If you have hardware wallets in your devices, which I sincerely hope will happen soon, we are working with a university in Germany now that is putting hardware wallets into little scooters. So we are moving there. We did something similar with Riddle and Code when I was still with Daimler a while ago. It's by far the best way to organize IoT or device-driven, asset-driven logic. And then you basically create, and now comes the big time, we're all in this for money, you need to do the settlement. And yes, you can transfer tokens if you want to, if you're happy with that, but that is not good enough for the real world. You need to leave double entry bookkeeping. There is simply no other way. So a distributed ledger, to shift a little bit from blockchain to a pseudonym for it, a distributed ledger such as Corda will do the job on a sub-ledger, on a transactional level, but, and this now brings us closer to ConCircle, to Unibright, and to the baseline protocol. This real money of the real world where the taxman comes, and the taxman is the most powerful person in the world, believe me that. My father told me, and he was serious, he's not afraid of the mafia, he's not afraid of some street crooks, he is afraid of the taxman, and so should we all be. So you need to take that very seriously. And the taxman counts your money according to what in big enterprises is 80% in the SAP. Let's not be unfair, there's other ERPs as well. But it's only counted there and nowhere else. So if you want to do business for enterprises, you need to cater to that. So yes, you need to be decentralized because it's simply easier, more efficient, it scales beautifully on a horizontal level, but you also need to stick to two decentralization points. Identities come from the government. Each of you has an identity document, most probably in your right-hand pocket, in the wallet, but that is given to you by the government. It is not by you, it's not by your mother, it's not by your father, it's given to you by the government, and if you check your passport, that doesn't even belong to you. So if you want to buy a house and go into a legal agreement, it doesn't matter who you say you are. It matters who the government says you are, and that will be the only identity ever approved, which means there is a root of trust. There's simply no way around it. Every single car that you see out there has a vehicle identification number. Of course, there's a centralized organization. It's the vehicle registration authorities and European organizations that keep track of that, and they assign those identities. There's simply no other way. So that is not decentralized, but that's just how it is. And then, on the other side of it, companies pay their tax, do their investor reporting, go to the stock exchange, Good. It must be. Do that based on the books. So, and the general ledger, how this big, humongous piece of the sink of truth is called, is centralized. There's also no way around that. So, and you need to be able to bridge between the two. So we use the identity triangle, human, company, and device, which is generic in itself, pure crypto-based, to establish all the physical facts. And then we have the blockchain and the distributed ledger and all of that, these nice protocols in the middle. And all we do it for mobility, we do it for the power grid, we could do it for hotels, it doesn't matter, containers, it doesn't matter. Anything that has access control, check in and check out, can be processed in this manner. All we do is identification, verification, contracting as in consent agreement, and last but not least, put the bookings. The money is secondary, believe me, the cash is secondary. Put the bookings where they belong, bookings being accounts receivable, accounts payable, and those, and that's the magic towards corresponding accounting, current accounting, accounts receivable and accounts payable at the very same time, fully consolidated across the whole ecosystem. If you talk to an existing accountant, they will tell you that's not possible because you need an invoice in the middle, but a distributed ledger, also known as blockchain, does that, which means the company that owes the money, accounts payable, and the company that will receive the money, accounts receivable, will have that booking in their books at the very same time, and because of the magic of ConsenSys, in ConsenSys we trust, they will agree that this is fair and square, and then settling that is peanuts. You can agree on daily, weekly, netting off, whatever. You bring a really low margin payment operator who handles that for you. That is really, really peanuts at the end of the day. All right, so that is then how it basically, DID identifiers, then actually very little of smart contracting in the middle, the blockchain essentially just being a glorified, serialized notary, message bus, whatever you want to call it, which is why I believe ultimately we will converge on something like the baseline protocol here. And then it needs to go out to the SAP, and ideally right now we are working with the colleagues from ConCircle to do that for us, so we have a direct ConCircle adapter that takes us from our blockchain. The money booking we do in Corda, not in Ethereum, there's various reasons for that. And then it goes via the ConCircle adapter into SAP. That's all nice and well, but that's one basically spoke in what should be a more general approach. So in total, there is now I mentioned two centralized parts. So we have, whoops, that is not the way I wanted to do this. 1, 2, here I need to click on this one. So we have here SAP, which we call Ledger to ERP, which I just mentioned. Those are our partners, by the way. So Ledger to ERP, which I just briefly mentioned. But then, of course, you also need the opposite way. We call it IBAN to Ledger. So to handle cash and being able to convert the cash internally to something we call internal value units, which is, it's really not a stablecoin because it cannot be traded. But it is a 100% representation of money that is in the hands of a bank. We're outsourcing the regulation for this. So in order to stay nimble and fast, we stay away from being regulated ourselves. So when it comes to this very, very, very harsh regulation in the banking industry, it's much easier. You go with a banking partner. You have the banking partner legally push the button when an internal value unit is being generated. It will be classified as e-money. That's pretty clear because we use it to settle liabilities across the partners in the ecosystem. So that's e-money right there. So the moment we do this, technically it works, but government is government, so that'll not work. So in this way, you have presented an ecosystem that is nice and usable for enterprises. Yes, it's decentralized. Yes, it's blockchain, but they don't need to shift mindset. And this is what this whole presentation is about. Yes, we come from the decentralized world because of the possibilities and the power it puts in the hands of the people that know how to use it. But it shouldn't be a pain, and it shouldn't be a religion, and it shouldn't be something I need to convince my business partner of. My business partner is doing their business, they're counting their money, and that's all they should do, and that's all I want them to do. Which means a normal company is using fiat money and putting their money into IBAN. Yes, they know what tokens are, and in their playful days or playful hours, they might do an NFT project here, in the big enterprise NFT project there, but it's not their core business right now. So you better make it easy to handle their IBAN. And they do keep their books on the SAP side, so you better make it easy to basically push stuff into where they actually count their money. All right, now how do you generalize this? You generalize this, and remember the part about the digital identities and the digital signatures. Now let's come to a very, very crucial part that comes with that protocol. It's called verified credentials. A verified credential is essentially a document that has been signed by legally identified parties. The closest, and actually it's not as cryptographically complete, but a very close way of thinking about this is DocuSign. So if you use DocuSign or DocSend or HelloSign, in fact, you're trying to do something that has been solved in a very elegant way by the DID standards. By the way, those are they're being standardized by the World Wide Web Consortium, which are the same people that have standardized URLs and URIs. So, and you basically now, you can create credentials. And a credential is a statement that me issues, I confirm with my digital signature that you have a driving license. Obviously, anybody can state that, but that's useless. So if I state that, for you to be able to use it, I, as the trust provider here, must have somehow credentials to my name that ultimately entitle me to verify a driving license. But once that is the case, then we have a verified credential, which is called a driving license. It gets better than that. If you think about what a ticket is, a ticket in our world, if I think crypto, has two ideal ways of representing it, and we're working on both. Actually, an NFT, if you think about what an NFT is, it's nothing but a token with a serial number. That's about it. So a token with a serial number and a ticket with a serial number very neatly mesh on top of each other, but that is completely not interoperable. The beauty about this DID protocols is they're completely interoperable. Ontology has their set, Ethereum has their set, WebDID doesn't even need blockchains, so the corresponding credentials can be carried with you, decentralized in your wallet, to be presented and autonomously parsed. It's completely self-contained. It says which signature algorithm to use. Those are all open source. Use the signature algorithm, verify the identity that signed it, and then you can believe this statement. So break it down, and these are the three major things. So, ticket. Ticket just basically means you have paid somebody. It could be a subscription right as well, but it means that somebody, remember the roaming part? Your SIM card essentially becomes a verified credential. Why? Because you were presented as a verified presentation. That's a little bit now tech talk, but what it means is somebody can challenge you for it. You present some crypto proof, and then that somebody knows, okay, you bought your SIM card from T-Mobile, and T-Mobile says you're good for this level of service. All right, here I deliver the service. Afterwards, because I got proof that this credential was presented to me, then I go with that, plus, and this comes with a smart contract, with my call detail records, with my billing records, which I also sign. I present that to T-Mobile, and T-Mobile, no questions asked, gives me my money. So, tickets are crucial. Tickets are basically these access rights. You pay me, I give you this credential, and that is self-contained, and you're on that chain, I'm on that chain, I don't even use a chain, it doesn't matter. I can verify this ticket legally. Then, invoice is the same part. Then, once I have an invoice, what's an invoice actually? An invoice is that whoever delivered the service, based on the original consent agreement, think of that as an attachment, now presents that this is now the invoice to be paid. And in the work, for instance, we're doing with the Energy Web Foundation and 50 Hertz in the balancing of, so in the power grid, they go one step further. So normally, a normal invoice, as you know it is, it has my signature on it, and then it gets approved on your side if you're a company, and okay, where's the contract for this? Let's check this, etc. If you look at online applications, you actually present an excerpt of this invoice to the user, and the user will countersign it. The moment you have that, you have self-contained, digitally verifiable, cryptographic proof that this invoice is legally valid. You can sell this, it's real money, because there's an industry called factoring that makes this real money. So all of a sudden, by this simple digital signature, no tokens involved. You have money in your hand, fiat money, legal money, nice money, at least no headache money, and which you can now sell to a factoring company, depending on who you are. They'll take 2 to 7 to 10% of your cut, but they'll pay you right now, cash, legal cash on your hand. So, and you do this, and they haven't even involved blockchain. So, and this is a very generic format. So add a little bit of schemata behind this, because obviously now, do I call the field invoice name or name of invoicee? You know, all this kind of Mickey Mouse little details that come in the middle of beautiful technical solutions, but can produce endless pain. You need to somehow address them. People have tried many, many times, I have my PhD on this, using ontologies and semantic blah, blah, blah on it. It never, ever works. I've never seen it work. Use schemata and be happy. That works. So put nice schemata between your business participants. Let them agree on, we use this schema. This is the name of the schema we use. It's referenced to schema.org, and here is our sub-classifications thereof. Can we please agree that the verified credentials that we're using follow the schema? Yes, we can agree on that. So already you got, at least on the key side of the key value pair, you don't have any more issues. You cannot prevent a total idiot of, if he's insistent to make a mistake, but you can pretty much eliminate the most obvious mistakes. And with this, you now have the ability to express self-contained business documents that are legally valid, that are monetary valid. And all you need now, and this is what brought us from our journey, we've been working on this already 3-4 years now. We originate in Daimler Mobility, where we incubated it for 3 years. Then we took a management buyout, bought it out, went through Outlier Ventures, et cetera, et cetera. So there's a whole lot of time behind this already. But now that we are approaching basically this level where it now gets, all right, plug our partners together, the most obvious way to use this now is to use something like the baseline protocol as basically the simple thing in the middle where I just throw my verified invoice or I throw my verified ticket in, and then it basically gets transported by what to me is essentially a consensus-powered message bus, gets transported among the individual parties, and we baseline it, meaning we anchor it and we timestamp it there, so that indeed, yes, I issued this ticket. On the content of the ticket, I don't need any crypto anymore. I don't need a blockchain, because remember, DIDs, verified credentials, digital signatures, handle all of that. All I need is timestamps and proof of the fact that two parties have looked at the same self-contained document, and there's a witness here that says both parties looked at this document. We don't need proof for the document. We don't need proof of the ticket. We don't need proof of the invoice. We don't need proof of the identity. I just need the witness that says they have both consented to this. That's all at this point in time. The consent I can even do without it, but I need the timestamp. That's essentially all you need left. And then you got a framework, think of it as a pattern or framework, to basically conduct business without any vendor lock-in, without buying any license, without using any predefined channel. Because, except for the baseline in this fact, which then is one predefined channel, the cryptographic part of it, and that's the beauty of these verified credentials and the DIDs, they are completely channel agnostic. To put it really to focus is, I can print out a verified credential, hand it to you, you travel with it, you scan it or you type it off with OCR, you scan it with OCR, and you can now continue working with that with whatever software or whatever mechanism you have, and it will continue to be valid, and it will continue to have the same semantic information. So this is essentially something where we believe these protocol layers, they need to be connected on the most efficient way possible. And to sum it up, what we're proposing here is use DIDs and verified credentials for anything that's physical fact. Use the digital signatures that come with that and the mechanism here. The beauty of it is self-contained, so you can carry it from any operating system, any network. I consider a blockchain essentially a big operating system. So you can take it from any operating system to the next, and it is valid, it can be parsed, it can be converted, and you can act on it. Then use your blockchain for the simple, business logic, counting the billable units and making sure that what you've collected has not been falsified in the process of aggregating them. Then use something like a distributed ledger to hold intermediate state among the parties. And then use something like the baseline protocol to pump it into where the truth will ultimately be, which is SAP and their competitors, which is not decentralized. And if and when you do this way, and the beauty of this is, if you look at it, most of you are techies, I believe. These protocols, they are nice, they're lean, they're easy to handle. Most of this is greenfield, so you don't get flooded by 500 megabyte of framework download before you've written your first line of code. You can basically start getting creative now, so it's still young, so you can be very effective. And writing these systems is counterwise to the intuition, much cheaper than doing something, you wouldn't even call it similar, but doing something in the same area based on existing systems, existing process will prove much more expensive than using these protocols, because they are so lean and they're so efficient and there's so little overhead involved that actually the lines of code, if you look at these systems, you're talking single thousands, maybe 10, 20, 30,000 lines of code, then you have written a humongous system already. If you compare that, I mean, look at any kind of legacy system, you will usually not see the lines of code, but it's hundreds of thousands or millions of lines of code, and it's only secure within the small bucket that it is running in, and even within that bucket, it's probably not secure. So this is essentially what I'm trying to position here. So I have 3 minutes. I'll basically just leave one slide open here. Anyway, the time's not here, which is one of the most exciting use cases we're working with Energy Web Foundation, and one of the 4 transmission service operators in Germany, where essentially everything I've said here gets applied to roaming, but this time roaming on the charging station, but roaming without, in the charging industry, you got something called EMSPs, electric mobility service providers. They are the people that make contracts with every charging station operator. They aggregate that, again, the aggregation with all the disadvantages that brings, put the app in your hand, and then you can charge. So the power producers, the one that really deliver the service, hate this, obviously. This is low margin business, and in comes this middleman, aggregator, and takes a big chunk of these already low margin business. Nobody likes them. But they are very successful so far because you need it. Now, based on what something called the Open Charging Networks, which is now part of the Energy Web Foundation, which has its own protocol called the OCPI, you can now produce the following. And I believe here in the Netherlands, everybody really is environmentally conscious. So I have an electric car now, that's beautiful, good. So the second half of the emission cycle I have solved. I'm not emitting them. But the power that goes into my electric car, how is that? Is that brown? Is that black? Is it whatever? I want pristine green, obviously. So I want to make sure that wherever I charge green. So what do? I find myself an operator in Germany, I believe in the Netherlands, you also have them. They only have wind power or solar panels. I make my contract with them. They sit somewhere in the nowheres in the north of Germany, 1,000 kilometers away from where I would be charging, but they produce electricity. And one thing is beautiful about power. It's fungible. An electron is an electron. So there is no such thing as green electricity or not. There is only balancing, and that is where what's called the transmission service operator comes in. They are doing this magic counting. So based on, again, DID, so I will get my contract with this power operator, which states I have a verified credential now. I come up to the charging station. I present this verified credential. My verified credential is verified. And then the CPO, the charge point operator, delivers power from whichever cable they have, whoever feeds the power in there, most definitely not my operator, feeds that power into my electric car. Then they count the time series the OCPI protocol brings us. I get that signed, a billing record gets issued, we do our magic here. Then at the end of this, however, that's where the true magic is. If all of this can be proven and verified and the identities can be submitted and this invoice is really self-contained, then the big power operator, the backbone of the grid, they're called transmission service operators, they do the balancing. So what they do is, I just charge 5 kilowatt hours, they just make it that way. It's called the virtual balancing cycle, virtueller Bilanzkreis. So what they do is, they say, all right, you, Lichtblick, which is the operator, you need to put 5 kilowatt hours into my network 1,000 kilometers away from here. You, CPO, you have just provided 5 kilowatt hours, and we make those 5 kilowatt hours the same. Because it's fungible, it's a matter of accounting for it, and it works. And that's how the energy business actually does work. So even though it might seem counterintuitive, what does power and mobility and the electric grid and charging have to do with any of this? I hope I managed in the last second that I still had to point out that the protocols underneath that are exactly the protocols that I was trying to explain in those 40 minutes. Thank you. Any questions or no questions? Okay, then.
All right, Harry Behrens, ladies and gentlemen. Woo! All right, so I believe now is the start of our happy hour hours. Yes, 2 hours of happiness, all for you guys. And then from 6 to 7, we will be streaming the Baseline show in this room and the other room, in this room. In this room. That's where we're streaming the Baseline show. We welcome you to come and watch it while you enjoy your happiness. As well, you're invited to join, maybe even share details about yourself, ask questions, anything. I believe we'll be online with John Wolpert at that point in time. So thank you, and be happy.
Nothing but darkness without you. I'm lost in a delicate maze. I can't see through the haze without you. So lost in a tunnel of stars. I see nothing but darkness without you. I'm lost in a delicate maze. I can't see through the haze without you. I'm so lost without your love. Won't you come find me now? I'm so caught up, I'm so in love. I don't think I can control it. I'm so mixed up. Could this be love? Or am I stuck in the moment? I saw you standing in the